Just few points that you remember that these were the points we have discussed in the last class. Okay, 57 number. Hello, and roll
Yes,
number
sir.
57. Yeah, yeah. Can you tell me what were the points that we have discussed in the previous class?
Yes, sir. Basic introduction.
Basic introduction, yes, but some of the few words you would have remembered about the whole lecture.
Microcontroller, microprocessor.
Yes, so we have talked about microprocessor and microcontroller. Then, so that is your subject name. 18 number. Roll number 18. Hello. Hello, may I have your 18 number? Yes. So tell me what were the things that we have discussed. Uh, Ramesh bhai. Okay, 45 number, tell me.
Sir, we talked about the definition of microprocessor, microcontroller, its basic architectural how it is built, its application, where it is used.
Okay, okay. Okay, so I have get you familiar with what the things that you are going to study in the whole semester in form of microprocessor and microcontroller. So in microprocessor, we will be studying basic definition, architecture, and basic interfacing about the the devices to the microprocessor. As we know that all the other devices are available external to the microprocessor, so that's why we need interfacing. Okay, and the microprocessor that we are going to study is what we called it as an 8085, which is an 8-bit microprocessor. Okay, then we discuss about microcontroller. So the microcontroller that we are going to study is an AVR microcontroller. We called it as an advanced virtual RISC. Okay, which is developed by Atmel. Okay, and the family member that we are going to keep it as a reference for studying this AVR microcontroller is Atmega32. Okay, which is also available in your Arduino Uno board. So that can help you to further development of the project. Okay, so we will be looking into the basic architecture of microcontroller. Then we will be looking into programming of microcontroller with help of assembly as well as with the C. I also give you an idea that what an assembly language programming is, what a C language programming is. We called it as an assemble, or we required a compiler for case of an higher level language programming. And we talk about some of the serial peripheral interfaces which are available with a microcontroller that can be used for connecting different sensors, then servo motor, stepper motor, DC motor, PWM, that is pulse with modulated signal and all that things. Okay, so we need to start up with our first unit, that is microprocessor. So in today's class we would be discussing a very basic related to what a microprocessor is, and we will try to see the definition of a microprocessor and how a computer system can be made with help or can be organized with help of a microprocessor. What is bus, what is memory, and all that thing we are going to discuss in today's class. So let's get started. I'm sharing a screen with you, so please let me know whether the screen is visible to you or not. So as soon as you see the screen, please let me know that yes, screen is visible to us. Then I'll start discussing about the unit number one, that is introduction to the microprocessor. Hello.
Yes, sir.
Just a minute, I got some issue. I need to resolve it. Is the screen visible, my friends?
Not
No,
yet.
sir.
No, sir.
Just a minute. Just hang on for a minute. Okay. Now is it visible to you?
Yes,
Yes,
sir,
sir.
it is visible.
Yes, sir.
Okay, so today we are going to talk about unit number one, that is introduction to the microprocessor. So let's get started. So the basics of microprocessor. So microprocessor is nothing but it is a silicon chip which include basic three things. Okay. So silicon chip means you would have seen that ICs, integrated circuits, in your digital electronics lab. Okay, so it is nothing but it is a black chip and it is having an external pins which are used for communicating with the external world. Okay, so microprocessor is nothing but it is a silicon chip which includes ALU. Okay, so this ALU is a heart of your microprocessor. Okay, so the full form of ALU is arithmetic and logic unit. Okay, so this arithmetic and logic unit is used for. Okay, we know that we need to have the processing of all the data. Okay, we need to have the processing of a data, and this processing of a data is nothing but either doing an arithmetic or logical operation. Either you may be going for an arithmetic operation over a data, or you will be going a logical operation. Arithmetic means addition, subtraction, multiplication, division, all that are arithmetic operations, and logical operation we are all aware of that, and or not, nor, x nor. Okay, all that are what we call it as a logical operations. So the data needs to be processed. Okay, so the place where the data is supposed to be processed is what we call it as an ALU, and it is in heart of any microprocessor. So this microprocessor is nothing but it is a chip, okay, which is having external pins, and the first unit that is present within a microprocessor is ALU. That is what we call it as an arithmetic and logic unit. Okay, the second component or the second thing that is present in your microprocessor is what we call it as an array of registers. Okay, now I think all of you know what is register. So can anyone tell me what is register? What do you mean by register?
Where we can store the data.
Okay, so yes, the place where we can store the data means temporarily I need to store the data. Let's say that for an example, I need to add two numbers, number A and number B. Okay, now you can see in this system that we are not having any kind of memory. Can you find it out of memory over here? No, you cannot find memory in your microprocessor. Microprocessor is not having a memory within itself. Okay, so there must be a memory. Okay, so the data A and data B both are available in a memory. Okay, now I need to get that data into my CPU. Means this is what we call it as a CPU or a microprocessor. I need to get that data into my CPU. So I need a place where I can hang on that data. So temporarily I can get that data into my registers. Okay, so yeah, microprocessor, if we talk about 8085, then it is having A, B, C, D, E, H and L. Okay, so these are the registers which are available in your microprocessor. A, which we called it as an accumulator. Then there is a pair of registers B and C, D and E, and H and L. So in all, we are having a 7 registers. So there is an array of 7 registers which are present in your microprocessor to just store a value temporarily, and you can process that values. Means you can perform arithmetic and logical operations onto that data which is available in the registers. Okay, at this time we need to take a note that we cannot do the processing of a data if it is external to the CPU. Okay, so this is what we call it as a load and store kind of an architecture. Means if I want to process the data, I need to load that data into my microprocessor. I need to process it, and then again I can need to store that data. Okay, so means you are not having a direct memory access in your microprocessor. Nowadays we are having a concept of direct memory access. Means if I want to process a little bit amount of a data in a memory, that I can directly do that. Means if I want to store a data which is coming from an external peripheral directly into the memory, previously it was the case that first of all it needs to go into the microprocessor, then the microprocessor will allot the memory place where it is supposed to be stored. But yeah, we can bypass this to just reduce the burden of your CPU or your microprocessor, and we again have a direct concept of what we called it as a DMA, direct memory access kind of a control. But in case of 8085 we are not having that thing. So we need to get the data into register, then we can process that with help of an ALU, and then we can again store that data back into the memory location. Okay, so now this is the process that a microprocessor used to do. But now, yeah, it cannot do that processes without any kind of control logic. Okay, so over here we are having an another system, okay, which is present within it, which is going to control all the things. Let's say for an example, if I want to process a data, the data is A, it is at memory location, let's say 1, and other data is B and it is at memory location 2. Now first of all I need to get the data A into my register, I need to store it somewhere. Again, I need to get data B into the register. I need to store that, and then I can perform the A plus B or whatever the operation I need to perform. Okay. Now all that thing would be done at a specific time with a specific signals. Okay. So yeah, there is what a system we called it as an control logic, which would be generating all the required signal. Means let's say a memory, there is memory 1, memory 2. Okay, so first of all I need to enable my memory 1, or before that I need to place the address onto the line. Let's say there are some address lines which are present, I need to place the address. At the same time the memory must come to know that this is the address I need to accept, and whatever the data that is present at the address I need to give it to the data line, and then the data line will get the data into my CPU. So this is a little bit complicated and complex process. So to make the process very smooth and accurate and all that thing, we are going to need a control logic. So this control logic is responsible for generating all the control signals which are useful for carrying out the task which a microprocessor needs to do. Okay, so this is a very basic thing about a microprocessor. So it is only having three things: ALU, register, and control logic, and some external pins for communication with the external environment. Okay, so this is what a microprocessor. Now if I talk about a microcontroller, then it is also a silicon chip, but it includes a microprocessor. So it is having a processor itself inside it. Means we will call it as a CPU. Okay, so there is a microprocessor which process the data. With that it is having a memory. So RAM and ROM, these are the basic memories that we can have. We can have IO, means IO section can also be there. So you can find it out over here. There is no IO section, there is no memory. Okay, with that there is no timer, counter, all that thing. So all that things are included onto a single silicon chip, and that single package we called it as a microcontroller. So this is a very basic point of difference between a microprocessor and a microcontroller. In detail, the points we would be looking into when we would be looking the microcontroller. There are so many list of points that we need to remember as a point of difference that generally being asked in your examination, that please list out the point of differences between microprocessor and microcontroller. So the point by point we will be discussing as and when the time come, but over here just I need to give a basic idea that what a microprocessor and microcontroller. Okay, so in microprocessor you cannot find RAM, ROM, IO, timers and serial peripherals. No, you can't find it out that thing in microprocessor. But in microcontroller, yes, with microprocessor you will be able to find it out all the other stuff. So this single package which is include everything on within itself, we called it as an microcontroller. Okay. Now, what is microcomputers? Okay, so a computer with a microprocessor as a CPU, okay, including memory and IO, etc., is what we call it as a microcomputer. Okay, so this is what a computer system, a general, a very basic, simple computer system will include this particular things. So it would be having a microprocessor. So this is a system. It is not a single silicon chip. It is in all a whole system. Okay, so in this whole system we are having different things. First we need to have a microprocessor which is having a processing capability with it. With that you are having different IOs and RAM ROM kind of thing. In an IO section, either you can connect keyboard for an input, you can connect display for an output. Okay, so this is a very basic construction of your microcomputer. Okay, so now let us try to have the definition of microprocessor uh, in form of a word. So we have understood that what a microprocessor is. A microprocessor is nothing but it is a CPU which is having a processing capability. It can be used to have a microprocessor. Sorry, a microcomputer. It can also be used to have a microcontrollers. Okay, so in a form of a definition, in a form of an arrangement of words, the microprocessor is a multi-purpose, programmable, clock driven, register based digital integrated circuit. So this is a clock driven register based, create the binary data as an input, process it according to the instructions stored in its memory, and provide the result as an output. So this is in all a completed definition of what a microprocessor is. Now let us try to see all the things word by word. The first is multi-purpose. Okay, so multi-purpose means it can perform multiple tasks. Now what it means by performing a multiple task? Now I think all of you would be using your laptop or a computer system. Okay, we would be taking that thing as a reference. So I think all of you would be using your computers, laptops and all that. So now in that, what you can do is you can open your Internet Explorer, you can open your VLC player, you can open your media player. At the same time, you can open your Word document, PDF. Okay, so this is what we call it as a multitasking. Okay, so it can handle a number of tasks at the same time. Means it is not developed or programmed, okay, for a single task. Okay, so you can perform multiple tasks, means a number of things that you can do at the same time with help of a microprocessor. But whenever we will be looking into microcontroller, it is a single task, means there will be a single piece of code running infinite duration of time and doing a simple single task. Okay, so we are having a multitasking capability in a microprocessor.
Hello, sir.
Program that can be written into your microprocessor, and according to that it will perform the task. Now it is also clock driven. Okay, clock driven, have I talked about your system? So whenever you open the properties of your computer, it would be telling you that it is i3 fifth generation at the rate 200 2 gigahertz. Okay, yeah, there is a clock which is required. Means I have told you that there are a computer, sorry, a microprocessor is in all our systems. Okay, now if every component of the system they will not be working in synchronization with each other, then the specific cannot be achieved. Okay, so there must synchronization between every component of your system. Okay, so that's why we are having a clock. Okay, so clock will help us for synchronizing everything. Okay, so it is actually clock driven. It is register based, means already we have talked about that whenever we want to data to be processed, it needs to get into the registers. Okay, so there must be an array of registers where the intermediate data which is to be processed are to be stored. Okay, and we know that it is a form of an integrated circuits, means it will be form of a black chip. I think all of you would have seen motherboard, and on motherboard there would be a fan which is being installed onto a chip, and that chip is nothing but it is a microprocessor. Okay, so this microprocessor accept the binary data. Okay, now this is why we go for conversion of decimal into binary, because microprocessor will not understand the decimal data. Okay, so the data that can be understood by a microprocessor is always in form of ones and zeros. Okay, so it accepts the binary data. It do basic processing in form of arithmetic and logical operations. Okay, according to what the instructions that you have stored. Okay, so suppose if I have instructed my processor to get the value from memory and add up and then again store back that result into the memory. So this is an instruction that I have given to my microprocessor. So it would be in form of an instructions which a microprocessor understand, and the sequence of instructions would be stored into memory one by one, and the microprocessor will read the instruction, and according to that it will perform the task. Okay, and finally it will show the result as an output. Okay, so this is a complete definition of a microprocessor. Any doubt? Hello, is there any doubt up till now?
No, sir, not
No,
not.
sir.
Okay, so a microprocessor is, we can call it as a mini computer. Okay, we can also call it as a central processing unit, which is on a single chip that contain millions of transistors connected by the wires. Okay, so this all these things, yeah, you would be studying a subject in your next coming semester, that is VLSI. Okay, so in you will come to know that all the operations that we use to perform addition, subtraction, multiplication, division, storing the data, getting the data, and all that thing, they are being done with help of transistors. So we generally rely on the CMOS technology. So there are million of transistors that used to support this type of processes. Okay, and they are all interconnected with the wires. So microprocessor is designed to perform arithmetic and logical operations that makes the use of small number holding areas called registers. Already we have discussed that it will take help of registers to do the arithmetic and logical operation. Okay. So the typical microprocessor operations that are included adding, subtracting, comparing to number, and fetching the number from one area to the another area. So this is very basic arithmetic operations that generally our 8085 used to perform. But nowadays the microprocessors, they can perform very complex task also. Okay. So the basic component of the microprocessor, already we have discussed that there would be an arithmetic and logic unit, which is actually the brain of your microprocessor. Okay, that perform the addition such as operations such as addition, subtraction, and all the logic operations that are and or nor, etc. Okay, it will take help of a small memory area. Okay, which we called it as an a register array. Okay, which is used to store and transfer the data, and all this thing would be performed with the help of a unit that we called it as a control unit. Okay, so it controls and execute the flow of data between the microprocessor, memories, and peripheral. Okay, and it generates the signals that permits the CPU to receive or transmit the data, all that thing. So we will be looking into the signals also, that what type of signals the control unit is supposed to generate in coming classes. Okay. Now, yeah, we talk about these things. Okay, ALU, register, control, but we haven't talked about memory. So there are some memories which are definitely external to the system. So if I want to access this, then there must be a bus, or we can call it as a wire connection. So the bunch of wire connection that is running between a memory and your CPU or a microprocessor, we called it as a system buses. Okay, so this is nothing but it is a network of wire which are electronic paths. We know it as an buses. Okay, so bus is nothing but it is a network of wire which is having a physical connectivity between the two component. Okay, so a system bus is a single computer bus that consists of the major component of the computer system. Okay, so the technique this was developed to reduce the cost and improve the modality. So we can classify three different type of buses. One we called it as an address bus, another we called it as a data bus, and third we called it as a control bus. So these are the three different type of buses which are available in the system. Sorry for the interruption. So the buses, the system bus, they are classified into three different one we called it as an address bus, another we called it as a data bus, and the third we called it as a control bus. So let us see how these buses are being organized in the microprocessor microprocessor system. Okay, so the first we called it as a control bus. So this control bus is having connectivity from the CPU to the memory to the IO section. Okay, so what the control bus will be doing is whatever the control signals that are being generated in by the this we already control unit. Okay, so we are having a control unit in a CPU. So this control unit would be generating a signal, means at what time which particular memory is supposed to be accessed, whether to access memory or whether to access IO device, whether to access input or whether to access output, at what time, and all that thing would be generated by the control unit, and they are being physically connected with the help of a bus. That is what we call it as a control bus. Okay. Now the another we called it as an address bus. Okay, why we called it as a bus? Because the data runs onto this from CPU to memory, memory to CPU, CPU to IO, IO to CPU. That's why it is called as a buses. Okay, so this address bus you can see from over here that always an address is generated by your CPU, means it is unidirectional from CPU. Okay, and it is always going into either memory or to the IO section. So it is a unidirectional bus. You can see It is one directional. Okay, there is no other way out. Okay, now address bus. Let me make a little bit thing clear over here, that how many number of address bus are there, that will decide that how many number of memory locations the CPU can access. Okay, now addresses, they would be in form of ones and zeros. Okay, so now let us take the things that we have studied up till now in your digital electronics from the point of view. Okay, now let me ask you that if I'm having a 4 bits, okay, how many number of different combination I can have if I'm having 4 bits, and each bit can take on value 0. I'm talking about binary bits. Okay, so if I'm having a binary bits, if I'm having 4 bits, how many number of different combination I can have out of this 4 bits? Anyone can answer? Let me go to
16.
45. Okay, 16. How it comes 16? Hello?
2
Hello?
to the power 4.
Huh? 2 raised to
4.
2 raised to 4. That is definitely 16. So if I'm having 5 bits, then obviously it is 32. Okay, if I'm having 6, then obviously I can have 64 different combination. Am I clear? Hello?
Yes, sir.
Yes, sir. Okay, so now let us try to see the same thing from the different concept. Okay, suppose if my address, okay, everyone know what an address is. So if my address is in a sort of binaries, okay, and if my address is limited up to 4 bits, how many different addresses can be located or can be pointed out by these 4 bits? Let's say I'm having 4 bits, okay, and the addresses, okay, they are binary addresses which is having a 4 bits only. Okay, so I can in all having 16 different addresses. Yes or no? Hello?
Yes, sir.
Okay, so suppose if I'm having a 10 bits of an address, so suppose if my address a location, okay, it is having a 10 bits, then I can have 1024 different location which can be pointed out with the help of 10 bits. That is what we call it as a 1k memory, 1 kilobyte of memory, 1024. Okay, so if I'll say that the address bus, okay, it is having a 16 different lines. Okay, so in all it can access 2 raised to 16 different maps. So the number of lines in an address bus can define that how many number of addresses that a system can locate, or how many number of addresses CPU can point it out. Okay, so that is about your address lines. Okay, so the address lines, how many number of address lines you are having, that will decide that what are the different memory location, how many different memory. Suppose it is having 10 lines, then it can only access 1k. If it is having 20 line, sorry, 11 lines, it can access 2k. So 16 line, definitely 2 raised to 16 different memory locations can be located, pointed out by the system. Okay, now there is a data line. So let's say I want to read the data from this memory. I know that its location is 1010. I will put 1010 on this address line. It will go in this. It will find it out that 1010 is my location. Whatever the data present at 100, it would be capped on the data line, and again the data will go into the CPU. Now you will find it out line. Okay, and the number of data lines, that is divided by what is the processing capability of your CPU. Suppose if I'll say that my CPU is an 8-bit microprocessor, then the number of data lines would be exactly 8. I think you understand that thing. Suppose if it is 16-bit CPU, then 16 data lines here. If it is 32-bit CPU or 64-bit CPU, 64 data lines would be there running bit CPU memory. Am I clear? So, hello. So, address bus, it is a group of wires or lines that are used to transfer the address of memory to IO. Address lines are unidirectional lines, and yes, we can have 2 raised to n lines already talked about. So, if I'm having 16 address lines, then it is 2 raised to 16, which exactly comes out to be 65536. Okay, which is nothing but 64 by 65 kilobyte of memory capability. Okay, so it can load this many 65,536 different memory locations. Am I clear? Am I clear, friend?
Yes.
Yes, sir.
Then the other is a data bus. So it is used to transfer the data into your microprocessor and my memory and IO section. And this data buses are bidirectional. Address buses, they are unidirectional, but data buses, they are the bidirectional because it is required to send and receive the data. Okay. So as already we talked about that if your processor is an 8-bit processor, then there would be exactly an 8 data line. So how many number of data lines are there in your system? That exactly defines what your CPU capability is. Okay, if it is 16-bit, then 16 data lines would be there. Okay, so that's why 8085 is known as an 8-bit processor because it is only having 8 data lines. The other one is a control bus. So already we talked about the processor uses a control bus to process the data. That is what to do at the selected memory location. Okay. So some of the control signals generally we use to find it out. I'll definitely will show that what is this read, write, opcode, fetch, extract, etc. These are some of the ALE, read, write, and all that thing. They are the different control signals that are generated. It is also bidirectional bus, and this is dedicated bus because all timing signals are generated according to the control signals. Okay, this is just how your microprocessor based system with bus organization will look like. So you will be having a CPU. Your CPU is nothing but it is a microprocessor with 3 different components: arithmetic and logic unit, register array, and control unit. Okay, and this is a bus system which includes all the 3 different buses: address bus, data bus, and control bus. Address bus is unidirectional bus, data bus is a bidirectional bus, and control bus is also a bidirectional bus. Address bus, it is used to provide the address, and the number of lines of this address bus will decide that how many number of memory location the CPU can access. Number of data line will decide the number of data bus that are and control signal, yeah, read, write, fetch, code, and all that thing. Okay, and memory generally we use to divide memory in 2 parts. One we call it as RAM and ROM. I don't think that I need to give you the point of difference between what is RAM and ROM because you know all that thing. RAM is a volatile memory, ROM is a permanent memory. RAM generally we use to store the data, ROM we generally use to store the program. Okay, so in most simplified form, a microprocessor based system consists of microprocessor, IO, and memory. These components are interfaced with each other or connected with microprocessor over a common communication path that we called it as in system buses. But in all, your microprocessor is master of the system and it is responsible for execution of the program. Memory is responsible for the storage of the program as well as for the data. And generally we are having 2 type of memory, ROM and RAM. Read only memory, which is non-volatile; random access memory, which is read write memory, which is volatile memory. IO devices are used to communicate with the external environment. Means if I want to input a data, I will use IO device. If I want to get the data out of my microprocessor, again I will go for the IO devices. Okay. In IO, generally we use keyboard, my mouse, and all that thing. And generally in an output devices, we use monitor and printers. So this was all from my side for today, which help you. Means maybe it may be this session may be very helpful for understanding the basic concept of what a microprocessor is, what a microprocessor based system is, what is address bus, data bus, control bus, what is ALU, register, control unit, and all that thing. Are you having any kind of doubt up till the things that I have discussed in the today's class? Hello.
No, sir, no doubts.
No doubt, please try to make all your doubts clear because you will not be getting your certificate chance to understand address bus, data bus, and all that thing, because in your higher classes it would be self understood that you are knowing all these concepts. So it is better to clear all your concept related to your number system at this stage only. So if you find it out that is something you are having a doubt within your mind, please feel very free to ask that. I'll try my level best to clear your doubt. Okay.
Yes, sir.
Yes, sir.
Okay, fine. Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.